Hello everyone. Welcome to the first video of ML series, machine learning series. Subject code is BCS602. So in this video, we'll be starting off with the first module and second module. So both these modules would be covered in one video itself. All the important theory topics, all exam related definitions, and all the numericals which have been appeared in internals and previous year papers are covered here. So make sure you don't miss out the video, don't skip the video and watch it till the end. And if you're new to my channel, do subscribe so that you don't miss out any of the upcoming videos. So let's get started. So in module 1, we have two parts. The first chapter is introduction and the second chapter is understanding data, first part. Then in module 2, we have understanding data, the second part, and basic learning theory. So now let's get started with the introduction. So under introduction, the first topic which we'll encounter is the need for machine learning. So in today's world, we know that the organizations are handling and generating large amount of data, right? So machine learning is very important to handle, manage this data efficiently, and extract meaningful insights from this large data. So let's see what is the need for machine learning here. First one is high volumes of data. As I told, like YouTube, Twitter, all these big companies produce large amount of data, right? So with every click, every like, every comment, we are generating some data, right? So all this data needs to be stored and all this data has to be processed, right? In order to process this data and reveal the patterns and insights from this data, we require machine learning. Next we have is reduce storage costs. Earlier we had to store the data in hard drives in physical medium, right? But nowadays it has all shifted to cloud storage. So cloud storage and data centers have become more affordable now. So thereby organizations are creating large amount of data sets, enormous data sets. So this affordability makes it very practical to collect the data, store the data and analyze the data on a very large scale. That's why we need machine learning. Then we have advanced algorithms. So by the emergence of deep learning and other advanced algorithms, machine learning has evolved over the years. You can say that it has the capability to recognize complex data patterns, from identifying the tiniest objects to understanding the natural language and so on. So for this advancement, we have again required machine learning here. Next we have is understanding data. So to have complete insight about how data has evolved, what is the actual meaning of data, we have to refer this pyramid diagram. Okay, knowledge pyramid figure. So first in this figure, first we have is data. From the lowest part we have is data. Data means it is raw or unprocessed facts. So it could be numbers, text, symbol, or anything. Okay, for example, mobile number is a raw data here. Sorry, 10-digit numbers are raw data here. Next we have is information. So information is the processed data. So when you take the data and it is processed to identify particular patterns or associations, it becomes a information. So if you take that 10-digit number, if you add +91, or if the number is in a certain pattern, we can say that it is a mobile number, right? So it from the data it turns into information. Next we have is knowledge. Knowledge is formed when the information is further condensed into actionable insights. For example, let's take historic data, historic sales data, which might show the snack products which are consistently sold more during the afternoon hours. So this insight, which is derived from the information, can be converted into knowledge or can be told as knowledge. So this knowledge is very helpful in business planning and promotions and all of that. Okay, then we have intelligence. Intelligence will evolve from applying the knowledge to make certain decisions. So as I told, the snack products which are consistently sold more during the afternoon hours, in that time I can give discounts or hire more employees so that customers need not wait for a long time. So from this knowledge I'm taking a particular decision, that's called intelligence. So with the help of machine learning, we can achieve this level by recognizing the patterns and making recommendations. Then comes the wisdom. Wisdom is the highest level. Wisdom is similar to human like reasoning and judgment. So wisdom will have a broader context, it will have a long term impacts and ethical considerations. So we can say that the machines have not reached this level yet, but soon in the process they are about to reach there. So the main goal of machine learning is to automate the journey, this journey from data to intelligence. So here we are enabling the organizations to make decisions, streamline the processes, and further do the necessary innovations. Okay, next we have is the conventional programming versus machine learning comparison. So we can say that in traditional programming, a programmer will have to manually define the rules, algorithms, give the problem statement, and then solve the problem. So this approach will work well if the data is well defined or predictable and it has structured data. Structured data means, let's say, sorting the data. You have given a data set, you have to just sort the data. It is very easy, right? What about the complex tasks? Complex tasks like speech recognition, autonomous driving, or any medical operation or anything. All in such cases, it is not practical to make use of traditional programming, right? So earlier AI efforts were made on the expert systems, but again those failed. So ML, that's when the ML emerged. Okay, so ML, machine learning, shifted AI towards data-driven models. Instead of relying on manual written scripts or manual written rules and regulations, the machine learning system learns from the data whichever is provided. That's why it is called as data driven model. So this model will help the models to learn, adapt, improve, and handle complex problems more effectively. So if you see this figure, the first one is for humans. Learning systems, the first one is for humans. That is, humans learn by observing, practicing, reflecting on their experiences. For example, how a child learns to walk, or any other example you can take. Then we have is learning system for machines. So machines learn by analyzing the data. So once the data is fed, certain algorithms are implemented, and thereby it is learning to take decisions. Okay, we are training the data, we are training the model, and thereby it can take decisions. So looking at the key concepts now, so this Tom Michel provided a formal definition for machine learning. Okay, so a computer program is said to learn from experience E with respect to a task T and some performance measure P if its performance on T measured by P improves the overall experience E. So let's understand this. Experience here means training the data, that is labeled images for image classifier or any other example. Next we have is the task. Task means a specific goal. For example, recognizing the objects from given images. Next we have is performance. Performance will tell us how well the model is performing. So it could be the accuracy, precision, recall, and all those things. So now let's look into building a machine learning model. So in order to build a machine learning model, there are 4 steps. First one is data collection. That is, we have to gather the data from different sources. It could be through the databases, it could be through the sensors, it could be through the web logs, and so on. Then we have abstraction. Abstraction means you are converting whatever the raw data you have obtained into meaningful features. For example, how humans recognize object. That's how we are abstracting the entire thing. Okay. Next we have a generalization. Generalization means we are developing a model that will generalize from the past data to make predictions on the newer data. So next we have is evaluation. Evaluation means we are measuring the performance using metrics like accuracy or precision. Then after this, we'll adjust the data, that is course correction. So we'll adjust the model, improve the performance wherever the correction is needed. So this was about building a machine learning model. Next, let's see into the formal definition of ML. ML, here again we have several theory topics which would be asked for 6 to 10 marks. So let's look into them one by one. Firstly, understanding the definition of ML. ML is a sub branch of AI, we know that. So the textbook definition says that Arthur Samuel stated that ML is a field of study that gives computers to learn without being explicitly programmed. So one textbook definition, and then the normal definition is converting logical and reasoning from experts' knowledge into set of rules and programs in order to construct or model the expert system. So this process comes under machine learning. So here ML model is explicit description of patterns within the data. So here the pattern could be either mathematical equations or the relational diagrams like trees or graphs, or the logical if else rules, or different clusters. Okay, so this was about ML model. Now we'll look into the relation of ML with other fields. Okay, so firstly we have AI. AI is the broad spectrum under which ML and deep learning come. Okay, so AI is the broader field focused on intelligent agents. We have seen what agents is in the first module. Capable of perceiving their environment and making decisions. So depending on the input is taken as sensor, and depending on the input, certain action is performed through the actuator. That is what agent refers to. So
it comes under the AI. So ML is the subfield of AI that extracts patterns and regularities from data to make predictions. So this was about ML. Then we have the deep learning. Deep learning is further a sub branch of ML that uses neural networks to model complex patterns and relationship of data. Here neural networks refers to the interconnected layer of neurons, like how we have neurons in our brains. The deep learning is based on that particular theory. So interconnected layers of neurons to process the data and apply activation function to generate the output. We'll be seeing this in depth in the 5th module. So this was about the basic ML intro. Now we'll look into the types of ML. Now we'll look into the labeled data and unlabeled data. So the data set in which each example is paired with corresponding label or output. So whatever the input, whatever you have, the data is defined properly or labeled properly. It falls under labeled data. So in data set of images, each one is associated with label that indicates an object or a category present in the image. So out of 1000 images, we can classify them as cat, dog and car. So that is what you are labeling the data. It is used in supervised learning. Then coming to unlabeled data, it is data set in which each example is not paired with corresponding data output labels. So that is opposite to this. So in a data set of text documents, the content of each document is provided, but there are no explicit labels indicating the sentiment of document. So this is used in unsupervised learning. So this was about labeled and unlabeled. Having the brief knowledge of labeled and unlabeled, we'll look into the types of ML. So firstly, we have there are 4 types majorly: supervised, unsupervised, semi-supervised and reinforcement. Looking into supervised, firstly, we have in supervised, a supervisor component provides labeled data so that model is constructed and generates a test data. So there are 2 stages here. That one is the training and another one is the testing. So based on the labeled data, a training model would be developed, and then a test data would be given as the input, and further the output or the results would be generated. So in supervised learning, there are of 2 types. One is the classification, another one is the regression. So classification is to predict discrete labels from set of finite labels. So the model learns from labeled data and is test on unseen data. So once you train the model, after training the model, you classify them and then you give an input of unseen data to assign the labels to it. So it is used in image recognition, disease diagnosis and all. Now let's look into then the example here. So here I have the labeled data. So these are considered as independent variables. So there are boxes and humans. So through the classification algorithm, the classification algorithm could be decision tree or naive Bayes or artificial neural networks and many others. So through this algorithm, we generate a model. After generating a model, you give an input, that is the new test data. And based on this test data, it will be labeled as a human or a box. So that's what is done here, simply, the simple definition of it. Next, we have the regression model here. So it predicts continuous variables. So it creates a regression tree. In order to generate a regression tree, we make use of regression model. So it predicts continuous variables like price and temperature. Model learns from a fit of line or function, that is through linear regression. So predicting product sales based on weekly data or monthly data, these come under the continuous variables, right? So we make use of regression model here. So the algorithm used here is linear regression, polynomial regression, and so on. Now looking into the unsupervised part. So an unsupervised, it is learning without the labeled data, that is unlabeled data. The model identifies patterns and relationships in the data. So firstly, we have clustering. So clustering is group object based on the attributes into disjoint clusters. So you took the unlabeled data which comprised boxes and humans, and then through the clustering algorithms, it was further classified or divided or clustered into 2 parts. That is one which has humans, that is similarities match here, and then on this side we have clustered to where all the boxes are kept. So this was about clustering. Then we have semi-supervised. So in semi-supervised, we have it is combination of labeled and unlabeled. So here the unlabeled and labeled data is taken. So application is pseudo labeling is done, oftenly used to combine labeled and unlabeled data set for the learning. Then we have the reinforcement, that is agent interacts with environment, receiving rewards and penalties based on its action. So each and every time the agent generates an action, a reward would be awarded, a reward would be given to it. So goal is to maximize the cumulative rewards over the time. So if the rewards are more over the time, that means whatever the process or the operation was expected to be done has been successfully completed quick in a certain time is what it refers. So it is an approach which involves trial and error, learning from the actions and their consequences. So it is used in game playing and robotics and all. Then we have they can ask the applications of ML. It could be used in image processing, data science, medicine, natural language processing, telecommunication, banking, business, gaming, and many others. Then we have the challenges of ML. So if the problems are not proposed clearly, that is ill-posed problems, it could lead to challenges. Then we have huge data. When the data set is of large quantity, it again creates a problem. Then the complexity of algorithms. The algorithms being used here are very complex. Then we have the bias variance, that is underfitting or overfitting condition can also happen here. Next we have the ML process. So firstly we understand the business, then understand the data, then we perform the pre-processing, then we have the modeling, and then the model is evaluated, and then once evaluation is done, the deployment of model is done here. Let's move on to the next topic. Here we have from the introduction to data topic, we have big data. So big data is large volume of data. So the characteristics of big data comprises of 6 V's. So the first one is volume, that is volume is stored in petabytes or exabytes. Then we have the velocity, that is fast arrival of speed. Then we have the veracity, that is confirming of facts and believability. Then the variety, here the data could be graph or video or audio map, anything. And then the validity, that is accuracy of data. The data which you have obtained need to be accurate enough to perform the further operations. Then we have the values here, that is value of data which is extracted. Further, the types of data we have structured data, that is when the data is organized properly, it falls under structured data. Here we have the record data which is stored in a matrix. Here the rows are called as records and columns are called as fields. Then we have the graphical data. An example to it would be the web pages. Then we have the data matrix, in which the numeric attributes or the vectors or points or the dimensional space could be stored. Then we have the unstructured data. So in unstructured data, we have video games, images, programs, blog, text documents, or 80% of the organizational data falls under the unstructured data. Then moving on, we have the semi-structured data. Here we have XML data, RSS feed, and hierarchical records. Then the last topic by big data analytics. So big data analytics assist business organizations to take the decisions depending on the analysis which they have performed. Data analysis is activity that takes the data and generates useful insights and the information required for the companies. So types of data analytics, we have a descriptive, that is here we are describing the entire process or whatever the problem is. Then we have the diagnostic. So in this a solution to the problem would be addressed. Then we have the predictive. So depending on the data and the analytics, the further trends could be predicted here. And then the prescribe. So depending on the predictions or the diagnosis, we can say that if the company is in loss or profit, certain prescriptive measures could be given. So that is what prescriptive data analytics refers to. Moving on, we have the binning techniques. So this is the problem. Consider following set. So set comprises of all these values. Apply various binning techniques. So here we have 3 binning techniques. First one is smoothing by means. So the next one is we have smoothing by bin medium, that is to replace the value here. And then we have smoothing by the bin boundaries here, that is we replace the closest bin boundary here. So starting, let's write the solution first. So by equal frequency bin method, data can be distributed across the bin. Let's assume that the bin size is 3. Okay, so bin 1 could be written as 12, 14 and 19. Bin 2 can be written as 22, 24 and 26. B1, B2 and B3. Then we have B3 as 28, 30, here we have 28 also. 28, 31 and 34. So these are the bin values. By the first method, I can write bin 1 as, by smoothing this I get the value as 15, 15, 15, and for this, considering the mean here, for 12, 14 and 19 I get 15, so I wrote 15 directly, and for 22, 24 and 26 I get 24. Then for bin 3 I get 28, 31 and 34, 31, 31 and 31. Using the bin boundaries method, so I can get for 12, 14 and 19, I can get 12, 12 and 19, that is for bin 1, and for bin 2 I can write 24, it was 24, 22, 24 and 26, so I can write 22, 22 and 26, and bin 3 could be 28, 34 and 34, because this is the closest one, right? And here this is the closest one. So that's how bin boundaries is done. So from here on, this is the end of theory topic. Now we have only the problems here in the second module. So the first one we have is, so this is a set of data, the values are given here. We need to find mean, median, mode, range, standard deviation and the variance here. So in order to find mean, I hope it is very easy. Sum of all these divided by the number of values present here. So we can get 17.5 directly. In order to calculate the median, that is the middle value of the entire data, I will consider n plus 1 by 2. Okay. So here n value is 6, so 6 plus 1 by 2 is 7, 7 divided by 2 is 3.5. So value of 3.5, fifth item would be considered. 3.5th item is not present here. It would be in between 3 and 4, right? So I will consider 3 and 4th item and divide it by 2. So 15 plus 20 divided by 2, I get 17.5. One major rule before solving all these is to arrange the data in ascending order. Okay. So assuming that the data is here, I have taken the data in ascending order only. That's why I have directly calculated it. If not, first step would be to do this. Then we have mode. Mode is the number or the data which has occurred most number of times. It has high frequency. So here there is no data which is repeated twice, thrice or n number of times. Then coming to range. Range is the maximum versus the minimum. I get 30 minus 5 is 25. Then comes the standard deviation. In order to calculate the sigma, we can make use of calculator. So that is, I'll show you how to do it. Mode. In mode we select statistics, that is 3. And in statistics we select 1 minus var. And then here we enter the data 5, 10, 15, 20 and 25 and 30. So 5, 10, 15, 20, 25 and 30. The data is entered. Once the data is entered, press AC. Now press shift and press stat 1. Now here select 4 var and then select 4 again SX. So you get 9.3541. So even if you calculate it using the normal, the traditional formula, you get the same 9.35. So sigma is equal to summation I is equal to 1 to n x minus x bar whole square by n minus 1. So this is the formula for standard deviation. Instead of substituting the value here, directly calculate it using the calci. Then for variance, it is the square of standard deviation. So 9.35 square I get 87.5. Then we have the 5-point summary. 5-point summary comprises of the median and then the interquartile range. Interquartile range, in that I have Q1 and Q3. So 1, 2 and 3. Then I have the semi-quartile range and then the box plot. So drawing all these, formulating all these three would come under 5-point summary. So the data would be given. I need to firstly find the mean here. That is the, I need to find the median here. That is the middle value. Middle value is considered as Q2. Then followed by that, I will form two sections here, right? In this section, whichever is the middle value would be the Q1, and in this section, whichever is the middle value would be the Q3. Q1 and Q3 is done. Finding the range now. That is Q3 minus Q1 interquartile range. I get 3. That is 7 minus 4. I get 3. Then I have semi interquartile range. That is 3 by 2. Whatever I've got here by 2. I get 1.5. Now I need to represent it using the box plot. So from 8 to 2 I have the data. So put dots there. And at 4 Q1 starts, and at 7 Q3 ends. So put lines here, and then at 5 there is Q2. So put a box from 4, 5 and 7. So this was about box plot. Then skewness formula need to be remembered. This may not be asked, I'm not sure about it. It was not asked in internals. So then we have kurtosis also. So kurtosis also, this is the formula. Then we have covariance and correlation. So in order to find the correlation, we need to find the covariance first. So formula of covariance is 1 by n summation I is equal to 1 to n xi minus e to the e of x into yi minus e of y. So here e of x is the mean of x and e of y is the mean of y. So x and y values would be given. Find the mean of them and then write this formula. So again you can make use of calc here. So write an equation, write the standard equation, that is here xi minus e of x. E of x is constant, that is 13.5, whereas xi value would vary. X1 would be 10, x2 would be 12, x3 would be 14 and x4 would be 18. Similarly 10 minus 13.5 into 40 minus 44 plus again 12 minus 13.5 into 48 minus 44, it will continue till n value reaches, till it reaches 4. Instead you can make use of calc. You can write the standard equation, that is x minus, here I have e of x value as 13.5, so 13.5 into, again I'll write y minus I'll write 44 here. I'll solve this. So first I'll enter the x value, that is 10, and the y value, that is 40. So I get 14. Write 14 here first. Okay, 1 by 4 you keep it outside. Inside the bracket write 14 here first. Next I have 12 and 18. 12 and 48, sorry. I write 48. I get minus 6. So minus 6 is entered here. Then again 14 and 56. So I get 6. So 6 is entered here. Next I have 18 and 32. 18 and 32. So I get minus 54. Minus 54 is entered. So perform the addition of all these. You get the final value, correlation, covariance. Once the covariance value is calculated, you can find the correlation, that is covariance of xy by sigma x and sigma y. We have previously seen how to find the standard deviation in the previous question, right? Similarly, make use of the features available in calc. You can easily calculate sigma x and sigma y, and then divided you get the correlation value. So this was about correlation and covariance. In case if they ask us the visualization part of the data, we can they can give bar chart or pie chart or histogram, dot plot, box plot, stem and leaf chart or line chart. The data would be given here. Two variables would be given, x and y. So constructing a bar plot, one would be taken as x and the other one would be taken as y, and depending on the value we plot it. We make different separate boxes. And then for pie chart we calculate the sum, and then we formulate for each one. That is for 4.2 we find the sum of all this. Firstly we get 60, right? So 4.2 by 60 into 100, that is 7%. So out of 100% of a pie chart, 7% would be allotted to the 4.2. When age is 1, the weight 4.2. Okay. Then we have histogram, that is continuation of the difference between bar plot and histogram is here you create separate boxes, whereas here it is continued. Okay. Then box plot, we have seen it in the previous question, how to calculate the box plot. And the dot plot also, it's similar. Create dots here on the points and then put different dots or lines here. And then coming to the sixth one, we have is stem and leaf. So suppose the values are 4.2, 4.5, 4.7 and all these. So in order to calculate the stem and leaf plot, before decimal, whatever is there, 4, 5, 6, 6, 7, 7, 7, 8. So 4, 5, 6, 7, 8 are common. I'll write them in stem part. After that, whatever is there, that will fall under the leaf part. So here I have 4.2, 4.5 and 4.7. So it will be 2, 5, 7 here. So that's how we write for stem, that's how we write for stem plot and leaf plot. And for line chart, it is the simple. For this extension of this only, you connect the dots, you get the line chart. Next we have the Gaussian elimination method. So we need to solve the given variables using Gaussian elimination method. Our first step would be to write the A is to B matrix. So this would comprise of A values would be on whatever is there on the LHS. So 2, 1 and 4. All the coefficients of x, y and z. 2, 1 and 4 here. And then 4, 11 and minus 1 here. and then 8 minus 3 and 2 here. And on B part, whatever is there on the RHS would be written. So 12, 33 and 20. So my main aim here is to convert the upper triangular matrix to get this matrix in the form of upper triangular matrix. That is, this part should be converted to 0. That is my main motto. If you look in YouTube, there are they complicated, but then understanding it in a pretty simple way, you need to make these three values 0. That's it. Once these three values are 0, I'll explain you the next step. Okay, so first I'll get this value as 0. So this is row 1, this is row 2, and this is row 3. So what I'll do, row 2, I'll perform an operation. Row 2 needs to be updated such that R2 minus 2 times R1. So when I multiply 2 here, 2 here, 2 here, 4 minus 2 into 2 is 0. So here I'll get 0. So I'll write the updated matrix here. After performing the operation, I'll get upper part would be the same. And here I would get 4 minus 2 into 2, that is 0. So I'll write 0 here. Next, here I have 11. So 11 minus 2 into 1. So 11 minus 2 into 1, I get 9. So I'll write 9 here. 12. That is 9. So I'll write 9 here again. Now I'll write this part as it is because I've performed operation only on R2. So I'll write this as it is, 8 minus 3, 2 and 20 here. Now my next operation would be R3, writing R3 as R3 is equal to R3 minus 4 times R1. So writing the updated matrix now, above it will be the same 2, 1, 4, 12. Here also it will be the same 0, 9 minus 9 and 9 here. Here it would be 8 minus 4 times of 2, that is 0. So I'll write 0 here. Here minus 3 minus 4 times of 1, I would get minus 7. Then I get 14. Minus 14 here. And then on this side, here I have 20 minus 4 into 12. I get minus 28 here. So these are the values I've got. So my aim was to get this particular, these particular values as 0. 0, 0 is obtained. Now here minus 7, I need to convert it to 0. So for this, what I'll do, I'll write R3 as 9 times R3 minus 7 times R2. So if I write the matrix, I'll get 2, 1, 4 and 12 as it is. Here also 0, 9, minus 9 and 9 here as it is. Here 0, 0 would be there. Here I'll get 0. I'll explain you. 9 into minus 7 minus 7 into R2 value is minus 9. So 9 into minus 7 and 9 into minus 7 I get 0. And here I get 9 into minus 14 minus 9 into 9, that is minus 189. And so once I've obtained this, all these three, the upper triangular matrix, this part is 0, my next step would be to consider the last row. Consider the last row, we get minus 189 is equal to minus 189. Here this row was for z, right? This was for y and this was for x. So I'll write z here. So I get z is equal to 1. If I cancel these two, minus 189, minus 189. Now I'll consider the second row. I get 0x plus 9y minus 9z is equal to 9 here, right? Now z value I know it is 1. So I'll write 1 here. So send this 9 that side. So y is equal to 18 by 9. 9 ones are 9 twos are. Y is equal to 2. I get 2 here. Now considering the first row, I get 2x plus 1y plus 4z is equal to 12. Y value I know it is 2. So 2 here. And z value I know it is 1. So 1 here. 2 plus 4 is 6. So 12 minus 6 is 6. And here I have 2x. So x is equal to 3. I have obtained the required values, that is z value, y value and x value. So this was about Gauss elimination. So for the main aim is to convert these three, the lower part as 0. Suppose here they have given 3 equations. If they have given 2 equations, then my matrix would be of the form x, y, z, w and here 1 and 2, some coefficient. In this case, you need to convert this as 0. This Z as 0. So that's about Gaussian elimination method. Now we'll look into the LU decomposition method. So for this, LU refers to A is equal to, we need to write it in this form, the output in this form, LU, where L is the lower triangular matrix and U is the upper triangular matrix. So from the given matrix, we need to convert it into that particular form. So starting, this is the matrix they have given. I'll multiply it with the identity matrix. So 1 0 0 0 1 0 and 0 0 1. So this is the identity matrix, right? So my aim is to apply matrix operations and reduce these two as lower triangular matrix and upper triangular matrix. Lower triangular matrix means this part should be 0. That is what they have said in the that's what we have seen in the previous question, right? Lower triangular matrix. Upper triangular matrix means this part, instead of 0, there has to be some value in it. So we need to perform operations such that both the changes happen simultaneously. So selection of the operations is pretty important here. Let me start from the R2 operation. R2, you can write it as R2 minus 2 times R1. So here I'll get 213 as it is. In place of 4, I get 4 minus 2 times of 2. I get 0. And then here 3 minus 2 times of 1. 3 minus 2 is 1. So I'll write 1 here. And then 10 minus 2 times of 3. 3 2s are 6. 6 minus 10. 10 minus 6 is 4. So I'll write 4 here. So R3 would be as it is, 2, 4 and 17. I am done with this part. Now I'll look into the identity part. In order to change this value, 100, I'll write it here. And in order to change this value, I'll write this is I'll consider it as L21. Okay. So for L21 operation, I'll take R21 by R11. R21 here is R21, A21 or R21, anything, is 4 by 2. Right, 4 by 2. So 4 by 2 is 2. So from 0 I have changed the value to 2. Right. Then I can write 1 and 0 as it is. And below also I'll write 0 0 1 as it is. My aim was to get here zeros and get here non-zeros. So we are done with the first variable. We have 2 more left. In the second operation, I'll write R3 as R3 minus 2 by 2 R1. So writing for this, I'll write the first one as it is, second row also as it is. For the third row, I'll write R3 is 2 here, 2 minus 2 by 2 is 1 and R1 is 2 here. So I'll get 0 here. Next I have 4 minus 2 by 2 of 4 minus 2 by 2 of 1. That is 3 here. I get 3 here. And then I have 17 minus 3. I get 14. 16, 17, 14 here. So I am done with changing the value of second number here. And on this side, I have 1 0 0 2 1 0. I need to change the value of this part. This is L31. Okay. So for L31, I can write it is A31 R31 by R11. R31 is 2, and then R11 is also 2. So I get 1 here. So I got 1 here, 0 as it is and 1 as it is. So I have changed this and this. Now these two are remaining. So I'll perform next operation. I'll write R3 is equal to R3 minus 3 times R1. So here I'll get R3 is 0 minus, so 0 minus 3 times 0, I get 0 here. So I write 2 1 3 0 1 4 and here 0. Next I have 3 here. So 3 minus 3 times 1, again 0 here. And then here I have 14 minus 3 times 4 here. 14 minus 3 times 4. Two here. So I am done with changing these values. I have obtained the lower triangular matrix. and on this side I need to get upper triangular matrix, so I'll write 1 0 0 2 1 0 here 1. This part I need to change. This part, this is a L3. In order to write value for this, I'll consider L32, that is I'll consider R32 by R22. R32 value is 3, R22 value is 1, so I get 3 here. So I'll write 3 here, and here I'll write 1 as it is. So my aim was to get this as lower triangular matrix and this as upper triangular matrix. I have obtained both. So they can ask these questions, these type of questions. So it is easy if they have given only 4 values here, 2:2 matrix, then it will be pretty easy to solve. Next topic we have is principal component analysis. In principal component analysis, we try to reduce the dimension. So the higher dimension data to the lower dimensional data, the reduction is done here. In order to perform this, we make use of covariance, eigenvalues, and eigenvector. So this is the question they have given. 4, 8, 13, and 7, the values are given here. We found the mean first, and then we identify the number of features here. Here there are x and y, 2 values are there, right? So 2 features, and number of samples given for each is 1, 2, 3, 4. 4 values are given. So I compute this table firstly, which comprises of x, y, x minus x bar, y minus y bar, x minus x bar whole square, y minus y bar whole square, x minus x bar into y minus y bar. I perform all the operations, find out the values. Then I draw this matrix which comprises of x and y this side, x and y this side. And here I'll be computing the covariance. So covariance of xx, covariance of xy, covariance of yx, and covariance of yy. By the obtained values, I'll be finding all these and then fill the value in the covariance matrix. Now from here I'll be finding the eigenvalues, that is determinant of s minus lambda I. S is the value which I had obtained here, I wrote it, minus lambda times I is the identity matrix I have written. So next I'll multiply this, so I get 14 and minus 11 here, minus 11 and 23 here. This lambda would be multiplied inside, so I get lambda 0 0 lambda. Now perform the subtraction operation. So 14 minus lambda, minus 11 minus 0, minus 11 minus 0, 23 minus lambda. So solving this, I get lambda 1 and lambda 2 values. So solving the quadratic equation through calci, I can easily get the lambda 1 and lambda 2 values. So once these eigenvalues are obtained, for each lambda I need to perform two times substitution. So first for lambda 1 I'll consider u1 and u2 here. So I'll substitute the lambda value, then I found the result, multiply it with u, so I get one equation, right? So this equation I send u2 to the other side. Okay, so if I send the u2 to the other side, I take it as t here, and then I get u1 and u2 values here, and this was for lambda 1, and then I normalize it. So this is the normalization procedure. Then I move on to the lambda 2, considering the lambda 2. So again perform the same operation. Now step 5 is to derive the new data set. So P1, P11, P12, P13, and P14. So all the values which I had previously obtained are updated here in this. So in the matrix, in the graph, I'll consider the new points and mark them as E1, E2, E3, E4, E1, E2, sorry. And then from E1, E2, I find the x and y values. So this was about the principal PCA topic. I would suggest that if you get this question, just skip it because it's pretty lengthy and time consuming. So this was about PCA. Next, so first we have the theory topic. What is the learning theory? And so let's start with this. So learning theory is a process of acquiring knowledge and expertise through study, experience, or being taught. So computers, this was a particular definition of learning theory. Computers can solve only well-posed problems, as these have well-defined specifications and have the following components inherent in it. So the particular problem should comprise of all these, that is class of learning tasks T, measure of performance P, source of experience E, and capital X as the input space, where small x is one instance or one input, and capital Y as the output space. So here, considering D to be the input data set, I have the solution, the question, the input, as well as the output for that particular instance for n inputs. So we have the unknown target function here, that is x derives y. Okay, so we need to pick a function g such that x derives y to approximate the hypothesis f. So all the possible formulae compute the hypothesis space. So that's what a hypothesis space refers to. So looking at this diagram, we have the training samples here and then the candidate formulae. So these come under the hypothesis space. So with the help of learning algorithms, we generate the hypothesis, that is g of x. So if this is different from the ideal target hypothesis, then it results to error. So that's what this diagram represents, this flow diagram represents. Next we have the training samples and the target function are dependent on the given problem. That is, the learning algorithm and hypothesis set are independent of given problem. So we'll look into the learning here. Definition of learning model would be comprising of hypothesis set as well as the learning algorithm. So looking at the learning types, so in order to acquire the knowledge, we can either acquire the knowledge by memorization or examples or critical thinking or self-learning. There are many others also. Do refer the PDF. I've uploaded it. Next we have design of learning system. So firstly, in order to design the learning system, we need to choose the training component firstly, and then the training function, and then representation of training function, and then later approximation is done to the training function. So this was about learning theory. Now we'll dive into the specific topic, that is concept learning. So learning strategy of acquiring abstract knowledge or inferring a general concept or deriving a category from the given training samples is what called as a concept learning. So it is a process of abstraction and generalization from the data. So it helps to classify the object having common relevant features. So in order to compare, contrast with the association of positive and negative instances in training data, and to classify an object, we make use of concept learning. So concept learning basically requires three things. So the first one is input, that is the training data set, capital T, and then the output, the target function, whatever you require, and then the test. Here new instances to test the learned model. So here we make use of small t. So this was about concept learning. Next we have hypothesis. So the hypothesis is given. So search through the hypothesis space in order to match the target concept. So that is about hypothesis. Then we have hypothesis space. So set of all possible hypotheses that could be chosen to explain the data set. This includes a range of potential models that could describe underlying patterns in the data. Then we have the version space. Version space is subset of hypothesis space that is consistent with all observed training instances. So once you obtain the output, I'll explain you in finders and candidate elimination, we need to derive the version space. Okay, so for example, color could have black, blue, white, red, yellow. These are the version spaces of color. Then we'll be using these terminologies. Question mark. If you see question mark, it denotes that attribute can hold any value. And if there is 5 here, it denotes that the attribute can't take any value. So this was about question mark and 5. Now let's look into the finders algorithm. So input, the positive instances in the training data set are considered as input, and then we need to generate a hypothesis H. So firstly we initialize H to be the most specific hypothesis, that is we fill everything by 5, that is it can't take any value initially. Then we generalize initial hypothesis for the first instance. So from the given table, consider the first instance and apply it to this H value, the most specific hypothesis. Then from the subsequent instances, if it is positive instance, then we check for the attribute value with H. So if it is positive instance provided here in the table, then we check, that is if attribute value is same, then we need not change it. If attribute value is different, then wherever the attribute value is changing, replace it with question mark, that is it can hold any value in H. Then if there are negative instances, then just ignore it, copy the previous H to the next H as it is. So this was about finders algorithm. And next we have the candidate elimination. So in this set of instances in the training data set, and then output is a hypothesis G and S. Here previously in finders we had only H, whereas here we have G and S. G is the most G is the most general hypothesis and S is the most specific hypothesis. So initialize G to maximally general hypothesis and initialize S to the maximally specific hypothesis firstly. And then we generate initial hypothesis for the first instance, like how we have done there. And we start comparing each and every instance. If the instance is positive, check for the attribute attribute value of positive instance and S. If the attribute value of positive instance and S are same, then no change. If it is different, then fill it with question mark. It was same as finders. Now we prone to exclude all inconsistent hypothesis in G with plus instance. So this I'll explain you while solving the problem. Then if we have negative instance, if it is positive instance, then update the value of S, and if it is negative instance, then update the value of G. So specialize G to exclude the negative instances. Add G to all minimal specializations to exclude negative instances. For examples, and be consistent with S. So if attribute value of S and negative instance are different, then fill attribute value with S value. If they are same, then no need to update. You can fill it with question mark. And then now remove from S all inconsistent hypothesis with negative instances. So we'll look into the problems now. We'll look into the solving the problems now. So the first one we have here is we have given the data set, the training data set here, which comprises of attributes like CGPA, interactiveness, practical knowledge, skills, communication, logical thinking, interest, and job offer. Job offer is the final output. Okay, this is positive instance here. This is also positive instance. This is negative instance. And here we have positive instance. Okay, so we need to solve this. Firstly, solve using find S algorithm. So for solving find S algorithm, firstly we'll take H naught, that is initial hypothesis, most specific hypothesis, as phi. Okay, fill it with phi, that is it can take any value. Okay, H naught, fill it with phi. Here how many instances we have? 1, 2, 3, 4, 5, 6. Six attributes are there, right? So fill it with 6 phi's. Okay, next I will start considering each instance. Okay, so this one is I1. I'll start with I1. So I'll write I1. I'll specify the instances Y, E, G, F, and Y. So now that I've specified here, and this is positive instance, right? So whenever I have positive instance, check for each attribute value with H. So if the values are same, then no change. If the values are different, then replace it with question mark. So here, if I compare it with H naught, I'll write the value here as S. Okay, so it would be here greater than equal to 9 is there. Here phi is there. Here also Y. Here also phi. So I'll get the same I1 value as it is. Okay, because phi says that it attribute can't take any value, but then when we are comparing it with the first instance, it can take these values. Like we'll update it, right? So 9, Y, E, G, F, and Y. So I'm done of finding the first H1 or S1 value. Now let's move on to the I2. I'll consider the second instance. So that is greater than equal to 9, Y, G, G, F, and Y. This is also positive instance. So I'll compare this with the previous H value or S value. Here I've taken it as S. So compare I2 and S1. So I get S2 here by comparing I2 and S2. If the values are same here, write it as it is. And if there's any difference, then put a question mark there. So here greater than equal to 9, greater than equal to 9, it's the same. Y same. Here there's a variation, right, between these two. So I replace it with question mark. Okay. Next, GG same. I have F here and I have Y here. So I'm done with finding the S2. Now I'll consider the third instance. I'll write greater than equal to 9, N, G, G, F, and N. Here I have negative instance. So whenever I have negative instance, for negative instance, ignore it, copy the previous H as it is. So they have said for negative instance, ignore it, copy the previous H as it is. So here I need not perform anything. For S3 value, I'll copy whatever S2 is there as it is. Okay. Greater than equal to 9, Y, question mark, G, F, and Y. Next, I have I4. I'll write I4 here. I4 comprises of greater than equal to 9, Y, G, G, S, and N. So this has positive instance. So I need to compare it with the previous H value, S3 value. Okay. So to get the updated S4, I can write these two are same. So it will be the same. Then here Y, so same. Question mark and G. So I'll put question mark itself because question mark states that it can take any value. So not only G, it can take other values also. That's what the question mark refers. So whenever we have question mark and G comparison, put a question mark only. Then G and G is there, put G as it is. F and S, there's a change in value, so put a question mark. Y and N, there's a change in value, put a question mark. So here we have reduced the final H value, final hypothesis value. So here if you see, we have neglected the negative instances and included all positive instances. So this was about find S algorithm. Looking at the drawback or the limitations of find S algorithm, that is it tries to find hypothesis that is consistent with only positive values. Only positive instances, if they are present, then only the hypothesis would be generated. But then if there are negative instances, we neglect it. Now we'll be looking into the candidate elimination. Candidate elimination for the given value here. They have specified the value here, right? All the data set is being specified here. In candidate elimination, we make use of S and G. S hypothesis and G hypothesis. S hypothesis is for the positive value and G hypothesis is when we have negative value. So firstly, we'll start with S naught. S naught being the most specific hypothesis, fill it with 5. So here 6, 1, 2, 3, 4, 5, 6. 6 instances are there, right? 6 values are there. Fill it with 6 5s. 1, 2, 3, 4, 5, 6. Now firstly, I'll take the I1. I'll write the I1, that is greater than equal to 9, Y, E, G, F, and Y. Now this has positive instance, so I need to compare I1 and S0. When I compare S0 and I1, I get S1. So update the S1 value. Here it will be the same. Next, I'll consider I2 now. So writing for I2, I have greater than equal to 9, and then here I have Y, and then here I have G, F, and Y. So as you can see, this also has positive instance, but then there's a difference. Like when you compare S1 and I2, here there's a difference. Right, E and G. So wherever there's a difference in value, put a question mark there. So greater than equal to 9, Y, question mark, G, F and Y. Okay. Next I'll consider I3. So writing I3 values greater than equal to 9, N, G, F and N. Here I have negative instance. So whenever I have negative instance, I need to update the G value, right? But G value I'll start it from the downside later. Now as of now, I'll keep this on hold. And S3 value would be the same, whatever is there here in S2. So greater than equal to 9, yes, question mark, G, F and Y. Okay. Then I have I4. I'll write I4. I4 values are greater than equal to 9, Y, G, S and N. So this has positive instance. So comparing S3 and I4, I get S4 as greater than equal to 9. These are same. Here also Y same. Question mark and G, I'll put question mark. G, F and S, I'll put a question mark here. Y and N, again a question mark. So I have obtained the final value of S hypothesis. Okay. This was one side of S. Now from this side, I need to write for G. Okay. So initially G naught value would be question mark. Okay. 1, 2, 3, 4, 5 and 6 question marks, because 6 values are there here, right? Next, for I1 instance, I got S1, right? Because it had positive instance. So here the values would be the same, question mark only for I1. For I2 also it would be the same only. But for I3, as it has negative instance, I need to update the value of I3 with G3, right? So here I can write, in order to update the G3 value, here I have negative instance, right? This one. So I'll compare this and S2. So if the values are same, then write it. Okay. So here greater than 9, I'll write only the first value, and then rest all I'll put question mark. Okay. Next, here I have Y and N, right? So I'll put Y. Okay. Question mark, Y, question mark, and question mark. Next, I have question mark and G here. So it is question mark as it is. And then G here. So you need not write it. FF need not write it. But then here I have Y and here N. So I'll write Y. Okay. All these are question mark. Here I'll write Y. 1, 2, 3, 4, 5 and Y here. So this is for G3 value which I have obtained. Next, I'll look into G4. So G4 was here. It was positive instance. So the updated here, whatever G3 was there, I need to update it. But then I'll write the first one as it is, greater than equal to 9. Question mark. But then out of these two, if you compare it with S4, then here YY is there, right? So, here question mark is there, here Y is there. So if you compare also, you'll get question mark only. But then here YY is there. So I can write question mark, Y, question mark. So this was for G4. So now that I have obtained S4 and G4, now I'll write the version space. So version space can be written by considering these two. Okay. So firstly, I can write greater than equal to 9. Yes, question mark. This is one hypothesis which I can obtain from this by comparing this. Then another one which I could obtain is greater than equal to 9, question mark. The good will be as it is, and then again question mark. Here question mark. Here I'll consider yes and good. These two I'll consider with this. So question mark, yes, question mark, good, question mark. So in order to get this, I've compared this one and this one. So next, in order to get this, I've compared this one and this one. Then to get this, I've compared this and this. And I've also compared this with this. So this was for candidate elimination. So if you have an option between finders and candidate elimination, I would say go with finders because it's pretty simple and you can solve it very easily. Next, we have the next topic, that is, we have another question here for finders and candidate elimination. So writing the finders first. So firstly, I'll take H0. Most specific hypothesis is filled with 5 values. Here I have 1, 2, 3, 4, 5, 6. 6 different values, right? So I'll fill 5 values. Then I'll take the first instance, I1. I'll write it sunny, warm, normal, strong, warm, and same. Okay, this has positive instance. So I'll compare it with H0. So I'll get the updated H0 or S1, which I can write it as SWN, SWS. Okay, next I'll write I2. So I2 values are SWH. SWS. So this again has positive instance. So I need to compare I2 with S1 in order to get S2. So when I compare these two, I get SS, it's the same, WW, it's the same, N and H is there. So wherever the values are being changed, I'll put a question mark there, and then SWS as it is. Next I have I3. So I'll write the I3 value, that is RCHSWC. So this has negative instance. So whenever negative instance is encountered, do nothing, but then write the S2 value as it is. So I'll write SW question mark SWS. Next I have I4. So I4 value, I'll write SWH SCC. So here this has positive instance. So whenever positive instance is encountered, compare I4 with S3 in order to get the S4. So here SS the same, WW the same, here question mark and H is there. So I'll put question mark. Here SS, so S, W and C values are changed to put a question mark. Here also S and C is there, so put a question mark. So here I have obtained the final hypothesis. This one was for finders algorithm. Now I'll write for candidate elimination. So I should include two hypotheses, S and G. S would be updated whenever I have positive value, G would be updated whenever I have negative value. So starting from the S, so S naught I took it as 5, most specific hypothesis. Here 6 values are there, right? 6 question marks. Then I'll start with the I1 value. So I1 value I'll write SWN SWS. This has positive instance, so update S1. S1 would be updated, so it will be SWN SWS. So yeah, now in the previous question I had written it in this form, right, where I had updated S on one side and then G on one side. Instead you can do it directly also. You can write here only. You can get G1 as, see, S naught were these values, G naught would be question mark question mark question mark question mark question mark question mark. S naught would be most specific, and G naught or G would be the most general. General is question mark, specific is 5. So here G value would be question mark as it is. S1 G1 I have obtained. Next I'll take I2. I2 I'll write SWH SWS. Okay, again positive. So I need to update S2 value by comparing it with S1. So it will be S and S is there here, W and W, N and H is there, N is there, H is there. So I'll put a question mark, and then S, W, S are same. Now for G2 value, as it is positive instance, no changes are being taken place. So I'll write whatever is there in G1, I'll write it as it is. Now I'll consider I3. So let me write the I3, RCH SWC. So this was for I3. Now I3 has negative instance. So whenever I3 have negative instance, I need to write S3 as it is. Whatever is there in S2, write it as it is firstly. SW question mark SWS. I'm done with this. Now next, writing the G4 value, G3 value. Negative instance means G3 value should be changed. Writing the G3 value, here I have question mark. Compare I3 with S2. Okay. So here I have S and here I have R. So put whatever is there in S. Okay. Then followed by question marks. Firstly, 1, 2, 3, 4, 5, 6. So you need to compare only one instances and write it in this form. Okay. Like how I've done in previous question also. So I compared S and R. So by having R here, I have got negative. In order to convert it into positive, I'll substitute R with S. So that's what I've done here. S question mark and followed by 5 question marks. Then I have W here and I have C here. So again put W value here. That is, first one would be question mark and then W followed by 4 question marks. Next I have question mark and H here. So it is question mark only. Next I have S and S. So S only. W and W. So W only. And S and C is there here. So S is there here, C is there here. So I need to put S. Okay. So S is at the last. So 5 question marks followed by 1 S. Okay. I hope you have understood this step. Even in the previous question, I hope you have understood this step. I'm done with I3. Now I have I4. I'll update the I4 value, that is SWH SCC. This has positive instance. So I need to update the S4 value. So compare I4 and S3. So when I compare S and S, I'll put S itself, W and W, W, question mark and H, question mark, S and S, S itself, W and C, question mark, and S and C, question mark again. Now writing the G4 value, here I have Sunny, I'll write it as it is. So S, question mark, question mark, question mark, question mark, question mark. Followed by that, whatever is there in warm, I'll write it as it is. 6. And then this S also I'll write as it is. Now that I've obtained the S4 and G4 values, now I need to write the version space, right? So version space by comparing S and G. So writing the version space, S4 would be SW question mark S question mark question mark, and then G4 would be S question mark and then W question mark. Here if I write, see, if you check here, I have S here, but then for positive instance I need to get C, right? So I need not consider this. I can put question mark here. Okay, so I can write question mark W question mark question mark question mark question mark. So writing the final value here, I get, okay, these two, and along with that I get S question mark S question mark, and then I have S W, then I have question mark W question mark S question mark. So I have obtained these values by comparing these. Okay, so next, see, S W question mark, and then here question mark S and question mark, I have written S and then question mark as it is. Next, comparing these two with this, so SW question marks, and then this with this, so question mark W S question mark W. So this was about candidate elimination. I would